But when we started our journey into the world of physics, we started out with motion. And that's what we talked about in chapter 11. We learned about velocity and acceleration and speed and distance and displacement. And then when we moved on to chapter 12, we learned that motion is actually caused by some sort of a force, by a push or a pull. And then in chapter 13, we learned that we can use force to do work on an object. And now in chapter 14, all of our discussion is going to be about energy. And energy is actually defined as the ability to do work. So as you can see, we're just taking what we started on, we're just building on it piece by piece as we go throughout the semester here. So I just have some different things about energy that I want to go over with you about. So first of all, energy holds all of matter together. And that may sound funny, but if you think about it, you realize that, let's say for example, that you have a big log, a piece of a tree, you have a log, and if you want to split that apart, you have to exert a lot of force on that log to do it. You have to use energy. You have to do work on the log in order to get it to split into pieces. So therefore, something must be holding it together. And what we know is that energy actually holds matter together, not only at the macroscopic level, but at the microscopic level too. When we get a little bit later on, when we start our study of chemistry and we're talking more about atoms and molecules, we'll learn that there are forces even within the nucleus of an atom that hold that nucleus together, and that's all energy. So there is energy that actually even holds matter together, holds your body together, holds anything that exists, it holds it together. Okay? Second thing about energy is that I can change its form. So I can change it into work, because after all, energy is the ability to do work. And that's something that we even talk about in our everyday life, except we do have to be careful with that, because some of the things we say in everyday life don't apply directly to physics because of the type of language that we use and how we're defining some of our terms. But we do take energy, the energy that we gain from the food that we eat, to do work, to move things around, to rearrange things, or the fuel that we put in our cars has energy, stored energy in it, and we use that energy to then move our cars. So we can change energy that is stored into work. We can use it to do work. Energy and matter are actually interchangeable as well. And again, that's something that even probably for the most part in high school, we're not really going to be dealing with, because it requires a lot of advanced mathematics. But if you've ever heard of Einstein and his famous equation, E equals mc squared, what that equation does, and the man was an absolute genius, what it does is it relates energy and mass, and then you have to multiply that by c, which is actually the speed of light. And so energy and mass are directly related to each other. Now again, that's not something that we're even going to begin to talk about in this level of science. Depending on what you study later on, you may talk about his theory of relativity and how matter can change into energy once it approaches the speed of light. But at this point, we're not going to do that. But I do want you to be aware that energy and matter are interchangeable. They can switch back and forth. Or I can simply change energy into another form of energy. I kind of alluded to that already when I mentioned taking the energy that you gain from your food and turning that into energy that you use to kick a soccer ball or to move furniture or to clean the house. Okay, so energy can be changed into work, matter, or another form of energy. Another thing that is true about energy is that it is conserved in a closed system. Now, what do I mean by a closed system? Well, as scientists, we tend to make definitions of things and we'll put boundaries around things so that we can better isolate what we're talking about. In reality, there is no such thing as a closed system, but I could define a system as being exactly what I'm studying. So maybe if I have a system, and within that system I'm going to talk about a person, and I'm going to talk about the fact that he's kicking a soccer ball, and the fact that maybe somebody else is in this system and he hears the soccer ball. So if I draw a box around this system, within this system, energy is going to be completely conserved. Now, what we have to realize, again, there is no completely closed system, but we can get close, and closing a system off just actually helps us to study it a little bit better. Okay, so energy is conserved. I may change it to another form, I can change it to matter, I can change it into work, but it doesn't just disappear. I can't destroy energy. I also can't create energy. All of the energy that is in the universe, the total amount that's here always remains the same. It's the same amount that God put into this universe when He created it. We can't create anything, and in actuality, we can't destroy it either. Now, what happens is that energy can end up in a form where we can't harness it, where we can't use it for something else. But that doesn't mean the energy is gone. It's just in an unusable form. Okay? So, it's always conserved. You can't create it. You can't destroy it. And when we measure energy, we measure it in joules. And hopefully that doesn't surprise you, because when we talked about work, we measure that quantity in joules, because that's a force that's moved through a distance, a Newton meter, which is a joule. And if I'm going to use energy to do work, or I can change energy into work, then I'm going to have to be able to measure it in the same unit as I measure the work with. Okay? So just a few points there on work. I believe I'm standing out of the way, so if you need to pause the video to jot any of those things down, you can do that. And as we proceed through the chapter, we're going to talk about some very specific kinds of energy, and then later on in the chapter, we'll talk about how that energy is converted from one form into another.